Hey guys, welcome to the worked answers for the 2020 Day 1 MCAT exam paper. Let's get into it. So, question 1. Find the value of 3x squared plus 8 plus 2y squared plus x squared minus 2 when x equals 2 and y equals 3. So we've got this long expression here, 3x squared plus 8 plus 2y squared plus x squared minus 2, and it's a substitution question. We've been given values for x and y, so wherever we see x and y in our expression, we're going to substitute those values in. So we've got 3 and x is 2, and it's being squared, plus 8 plus 2y is 3, again squared, plus 2 squared minus 2. Okay, simplifying this, we've got 3 times 4 plus 8 plus 2 times 3 squared is 9. Plus 4 minus 2. Okay, multiplying out our brackets, we've got 12 plus 8 plus 18 plus 4 minus 2. And now just adding up all our values, we've got 12 plus 8 is 20, plus 18, 38, plus 4 is 42, and minus 2 is 40. So our final answer here is 40. And for this question, you'll get an achieved. Correct solution, no alternative here, so numerical errors not allowed. You need your final answer to be 40. This gets you the achieved. Okay, question 1b now. We've been asked to solve the inequality 3, 2 minus x, minus 2, 3x plus 1 is greater than or equal to 14, 1 minus x. Okay, so it's another long-winded sort of equation. We've got 3, 2 minus x minus 2, 3x plus 1. And this time it's greater than or equal to 14, 1 minus x. We've been asked to solve, meaning we want a value for x. And the first thing we're going to do is expand our brackets. So we've got 6 minus 3x. This is the expansion of our first bracket. So basically I'm multiplying the 3 by what's inside the bracket, so it's 3 times 2 and 3 times minus x. Okay, here we've got minus 6x and minus 2, remembering to include the operation here, so it's minus 2, not positive 2. And this is greater than or equal to 14 minus 14x. Okay, collecting like terms, so we've got values with x in them, and we've got single digits. Looking at our left-hand side, minus 3x minus 6x gives you minus 9x. And 6 minus 2 is positive 4. This is greater than or equal to 14 minus 14x. Okay, we want to bring our x's to one side. Let's move the 14x to the left-hand side, and we can say minus 9x plus 14x is 5. 5x. And at the same time, we'll take our 4 and take it to the right-hand side. So it's 14 minus 4, and that equals 10. So we've got this equation now. 5x is greater than or equal to 10. Dividing by 5 on both sides, you've got x is greater than or equal to 2. Okay, and solving this inequality, x is greater than or equal to 2 gets you the merit grade here. You achieved expansion of all brackets, so this step gets you the achieved. Sweet. Moving on to question 1c, we've been asked to solve the equation 3 over x plus 2 plus 5 over x minus 4 is equal to 2. So 3 over x plus 2 plus 5 over x minus 4 is equal to 2. Okay, there's probably a couple ways you can do this. What I'm going to do is cross multiply, alright? So I'm going to multiply diagonally, and I'm also going to be multiplying the denominators. So we've got 3 x minus 4 and we could even keep our fractions separate for now, and we'll say x plus 2 x minus 4, okay, plus 5 x plus 2, and that's over, once again, x plus 2 and x minus 4. And this all equals 2. Okay, now we can expand our numerators and combine into one fraction at the same time. We can do that because our denominators are the same, x plus 2 and x minus 4. So, once again, expanding the brackets, we've got 3x minus 12 plus 5x plus 10, and this is all over, and let's expand our denominator, x squared, plus 2x minus 4x is minus 2x, and minus 8, once again that equals 2. Okay, and at this point, we've got this quadratic on the denominator. Let's multiply by x squared minus 2x minus 8 on both sides to get rid of that sort of nasty denominator. It's the only way to continue making progress in this question. At the same time, we'll collect like terms. Okay, so we've got 3 plus 5 is 8x, minus 12 plus 10 is minus 2, and that equals 2, and bringing out x squared minus 2x, multiplying on both sides, we get this. Okay, x minus 2 is equal to, now we can expand our brackets once again to x squared minus 4, there's an x in here, 4x minus 16. And now we see we've got a quadratic forming. Let's take everything to one side, so we make it equal 0. Obviously quadratic is in the form ax squared plus bx plus c equals 0. So 2x squared, bringing our 8x to the right hand side, it becomes minus 4x minus 8x, which is minus 12x. And we've got minus 14. this point, always look for a common factor. We can see we've got a common factor of 2. So let's take that out. And we leave ourselves with a otherwise easier quadratic. So the 2 just cancels. And now we have to solve this quadratic. X squared minus 6x minus 7. We're looking for 2 numbers that multiply to minus 7 and 2 numbers that add, the same 2 numbers that add to minus 6. And they are positive 1 and minus 7. So we can say x plus 1 and x minus 7 equals 0. And solving for x, we can say x equals minus 1 or positive 7. Okay, and both solutions here, x equals 7 or x equals to negative 1, gets you the excellence grade. Your merit: simplification of the equation to a single quadratic. So, presumably this step here, merit, achieved correct arrangement for the numerator and denominator. And they've said the marking schedule says in brackets does not need to be simplified. So, this step here. No, we could say simplification, correct arrangement for numerator and denominator. So I think either of these steps gets you the achieved. Okay, moving on to question 1D now. Kitty draws the 3 shapes shown below with the lengths of the sides indicated. All lengths are in centimeters. Note, area of a triangle equals half base times height. And we could also say at this point, area of a 4-sided shape, so square and rectangle, we're working with rectangles here, is base times height. Okay, and the question asks, find the value of the total area of all 3 shapes given that x equals 6 and x plus y plus z equals 12. Okay, so you're asking for total area. And total area is, of course, the area of the triangle plus the area of our sort of horizontally orientated rectangle plus the area of our vertical rectangle. Okay, so all we have to do is use the side lengths that we've been given and substitute them in. So looking at our triangle, we've got, and before that we could even say area of the triangle is half base times height plus b dash h dash, or b1 h1 plus b2 h2. Okay, and now we substitute in our values. The base of the triangle is 2x. The height is x. We've got xy. And our vertical rectangle is xz. Okay, we need to expand our brackets for the triangle. It looks like 2x squared over 2, which makes it just x squared, and plus xy plus xz. At this point, we need to start looking at our x equals 6 and x plus y plus z equals 12. But first, we could say, once again, always look for a common factor. We could take x as a common factor here, and inside the brackets we'd have x plus y plus z, and already you can see that we've made it much easier for ourselves. So x equals 6, x plus y plus z is 12. And 6 times 12 is 72. Okay, for this question, you get looks like just a merit for this question. Area found, 72. The marking schedule mentions units, so centimetres squared, but they say units not required, so you'd still get the merit with just 72 by itself. You're achieved forming an expression for the total area, so this step here possibly. Okay, moving on to question 1e now. The question asks us to solve the equation 8 to the power of x times 4 to the power of x squared minus 6 equals 4. So 8 to the power of x times 4 to the power of x squared minus 6, and it equals to 4. And for this question, you might be tempted to, well, in fact, you shouldn't be tempted to divide by, I was going to say 8, but we've got 8 to the power of x there, which makes it even more complicated. For this question, and I always say it's a classic MCAT question, we have to be knowledgeable about powers. So in the MCAT, you want to know your powers of 2, 3, 4, 5, 6 even. The powers of 2 are 2 to the power of 1 is 2. We've got 4, 8, 16. And so solving this question, we're going to change the bases. We're going to convert them into base 2. So what this looks like, for our first term, 8 to the power of x, we're going to use 2 cubed equals 8. And we're going to say 2 to the power of 3. And then in brackets, x. Okay, and with that we haven't actually changed anything. 8 to the power of x is the same as saying 2 cubed to the power of x. Okay, for the 4 we're going to use 2 squared. So 2 squared, and then that's raised to the power of x squared minus 6. And just for the single 4, again we're going to say 2 squared. Okay, now we've got we have to know our indices rules. We're going to use powers on powers here, so 2 to the power of 3 times x, and then 2 to the power of 2x squared minus 12, so we're multiplying out the indices, and this equals 2 squared. Looking at our left-hand side now, we want to combine 2 to the power of 3x and 2 to the power of 2x squared minus 12 into just one term. And we have the same base, which is 2. We're multiplying, meaning we add the powers. So it's going to be 2 to the power of 3x plus 2x squared minus 12. And our right hand side stays the same once again. Now another one of our power rules. If the bases are the same, they equal each other, so it's 2. We can cancel them out and say the indices that they're raised to must also equal each other. So we're going to say 3x plus 2x squared minus 12 equals 2. And we can see a quadratic forming. Let's take everything to one side. We've got 2x squared plus 3x, and then minus 12 minus 2 is minus 14. And it's equals to 0. Okay, so we have to solve this quadratic. This quadratic is a little bit harder than the previous one we did, for the fact that a is greater than 1. Okay, so a quadratic is in the form ax squared plus bx plus c, and in this case a is greater than 1, it's 2, meaning the first thing we do here is multiply a by c, so 2 times negative 14 is negative 28. And so we're looking for two numbers that multiply to negative 28 and add to the b term, which is 3. Okay, and that will be positive 7 and negative 4. So we say 2x squared. Now we split the b term and we say negative 4x plus 7x. We haven't changed anything, we've just made 3x, split it into two parts, negative 4 plus 7 and minus 14, and that equals to 0. Now we chop the quadratic in half. We can draw a line to help us. We factorize the left hand side, so 2x and x minus 2 inside the brackets, and the right hand side plus 7 is a common factor with x minus 2 inside the brackets. And you know you're on the right track when those two brackets are the same. So 2x plus 7 becomes a factor, and x minus 2. And they equal to 0. And at this point we can solve for x. 2x plus 7 equals 0, meaning x must equal minus 7 over 2, or negative 3.5 we could say. And x minus 2 equals 0, meaning x must equal 2. Okay, and with that, two solutions, x equals minus 7 over 2 and x equals 2, gets you the excellence grade here. Your merit forms a simplified quadratic equation, so this is your merit here. And achieved, you've written at least two original numbers as correct powers of 2. You've written all three original numbers in base 2, even if the powers are incorrect. So, okay, so there's a couple different criteria where you get an achieved. Basically, you can get an achieved as early as basically our first step, so this one here. Okay, that's us for question 1. Moving on to question 2 now. The height of a person, h centimeters, can be estimated from the length of their forearm, f centimeters, using the formula h equals 3f plus 100. Use the formula to find the length of a person's forearm F if their height H is 160. So this is a substitution question. We've got this equation H equals 3F plus 100, and we've been given H, and they're asking us to solve for F. So we can say 160 equals 3F plus 100, and taking 100 to the left hand side, we can say 60 equals 3F, dividing by 3 on both sides, F equals 20. Okay, a fairly simple achieved question there. Once again, the marking schedule mentions the unit centimetres, but then actually not required for the achieved. So F equals 20 gets you the achieved here. Okay, question 2b. A picture is framed using 4 rectangular pieces of wood as shown on the diagram below. Find the area of the picture in terms of x, giving your answer in the form ax squared plus bx plus c. So we've got this picture here. It's got we've got some dimensions: x, 7x plus 3, x, 5x plus 2, 7x plus 3, 5x minus 2. Oh, and again x. So it looks like these sort of the corner areas are x. And they're asking us to find the area. Here, finding the area, the first thing we can say is the area of the picture, so it's a rectangle. First thing we can say is base times height, right? And then we have to decide what our base is and what our height is. So it's these measurements. Our base, well, that looks like 5x plus 2 minus x. So essentially it's this whole length minus this x in here. Okay. So our base, we can say that is 5x plus 2 minus x. And then our height, that will be 7x plus 3, and the same concept, it'll be 7x plus 3 minus x. So it's this whole length and then minus this x here. Okay, so 7x plus 3 minus x. So we can simplify our brackets. We can say 4x plus 2, and that's multiplied by not 7 but 6x plus 3. And now we can expand. The question asks us to give our answer in the form ax squared plus bx plus c. So using the FOIL method, so first, outer, inner, last, we're going to say 24x squared plus, we've got 12x plus 12x is 24x, and plus 6. And this answer gets you the merit grade here. Okay, achieved forming a correct expression for the area of the picture. So just setting up that equation gets you the achieved. So this step here. Sweet, moving on. Question 2c now. Solve the inequality 3x minus 5 all squared is less than or equal to 3x squared plus 1. Okay. So 3x minus 5, that's all squared, is less than or equal to 3x squared plus 1. The first thing we have to deal with is this binomial 3x minus 5 all squared. And so we can say, we could go ahead and expand, but let's write out our two brackets just to make it easier on ourselves. Less than or equal to 3x squared plus 1. So we've got 9x squared here. Our b term is 2ab, which is, I believe, minus 30x, and positive 25. And this is less than or equal to 3x squared plus 1. Taking everything to one side, I'm going to take the 3x squared plus 1 to the left-hand side, simply because having positive value for the x squared term is just preferable. So 6x squared minus 30x, and then 25 minus 1 is positive 24. And this is less than or equal to 0. Again, I remind you, always look for a common factor. We can take 6 as a common factor. And inside the brackets, we've got x squared minus 5x plus 4. And this is less than or equal to 0. Our 6 cancels. And we've got this quadratic x squared minus 5x plus 4. Factorizing this, it'll be x minus 4 and x minus 1 is less than or equal to 0. And so let's say for a moment that the equation equaled 0. Our two solutions for x would be x equals 4 and 1. But we've got this less than or equal to symbol. And so the easiest thing here is to actually draw out what's going on. So we've got our positive parabola. This horizontal line represents 0. And our values for x are 1 and 4. Those are our roots. Okay. And so if we're looking for less than or equal to 0, it's this region here. The values for x where the function is below 0. And so our answer will be given as a range of values for x. And that'll be x is less than or equal to 4 and greater than or equal to 1. Okay, I hope that makes sense. And this correct inequality, x is less than or equal to 4 and greater than or equal to 1, gets you the excellence grade here. Okay, your merit. Correct solving of the quadratic equation. So these solutions here gets you the merit, and achieved correct expansion and simplification of the left-hand side. So that was up here. Somewhere around here gets you the achieved. Okay. moving on to question 2D. A rectangular piece of paper PQRS shown on the diagram below is folded along line FH, so that P is moved to G. Okay, the following lengths are given: FP equals 2, PH equals 3, RS equals x plus 3, and QR equals 2x minus 5. And they say again, area of a triangle is half base times height. So we've got our dimensions here. The question's asking us to find the perimeter of the shaded region in terms of x. Before we do anything else, we can label FG, GH, and HS. So FG is going to be 2, GH is 3. This length here, HS, is going to be looks like 2x minus 5. So this total length minus the 3, okay, that is going to be 2x minus 5 minus 3, so 2x minus 8. And we've also actually got this length, QF, and that's going to be the total minus this FP. So that means QF is going to be x plus 3 minus 2, so x plus 1. Okay. Now let's go ahead and find the perimeter. So what is the perimeter? Well, it's the sum of sides of the shape. And we've got to substitute our side lengths in. So that is, and we're looking at the shaded region. So it's here, we come down, HS, GH, FG, and then back up. So working from the top and going clockwise, we can say 2x plus 5 plus x plus 3 plus HS, so 2x minus 8 plus 3 plus 2 plus x plus 1. Okay, all we have to do now is collect like terms. So we've got our values, our terms that have x, and just our single digits as well. Okay, so x is 2x plus x is 3x. We've got 5 and 6. So it'll be 6x. And our single digits, that'll be 5 plus 3 is 8. Minus 8 is 0. Plus 3 plus 2 is 5. And then plus 1 is 6. And have I made a mistake here, possibly? Looking at the marking schedule, we've got, just checking, there's my mistake. I had positive 5, not minus 5. Okay, so we've got, let's do our green numbers again. And we can say, okay, minus 5 plus 3 is minus 2, minus 8 is minus 10, plus 3 is minus 7, plus 2 is minus 5, and then plus 1 is minus 4. So 6x minus 4 is our perimeter, and the correct simplified expression for the perimeter gets you the merit grade here. You achieved establishing the expression, so our first step gets you the achieved. Okay, we got there in the end. Moving on to question 2D2. Find the value of x so that the area of the shaded region is 24 centimeters squared. So the first thing we have to do is establish an expression for the area of the shaded region. And we're going to say area shaded equals the total area of the shape. So we're forgetting about the folded part, and we're going to assume we have just sort of a full rectangle, or what was it, a full piece of paper, and then we're going to subtract the area of the folded. Okay, and we'd say area white because that region was white as opposed to grey or shaded. Okay, so we can say, the question says the area of the shaded region is 24, so we can say 24 equals, and now area total, it'll be base times height, and it will be 2x minus 5 and x plus 3. So 2x minus 5 and x plus 3. And our white, area of the white, so this region in here, that will be, well, we've got two triangles, and the area of, looking at this triangle, that is half base times height, so half times 3 times 2. And we've got two of them. Okay, so we'll keep all of that information in mind, as we'll say we've got two of them, two triangles, and the area for one of them was half times 2 times 3. Okay. So we need to go about expanding our brackets. Let's say 2x squared. Now plus 6x minus 5x is just positive x, minus 15. And then minus 2 times a half cancels out, times 3. So we've got 2 times 3 is 6. That's minus 6. Okay, so we can see we've got a quadratic starting to form. Let's take everything to one side. Let's simplify. So we're going to say 0 equals 2x squared plus x. Now minus 15 minus 6 is minus 21. And we take our 24 over. So it's minus 21 minus 24, which is negative 45. Okay, we multiply A and C. 2 times negative 45 equals negative 90. So we're looking for two numbers that multiply to negative 90 and add to the b term, which is just 1. And they are positive 10 and minus 9. So we split our b term now, 2x squared plus 10x minus 9x minus 45. And we say that equals 0. We draw a line, factorize the left-hand side, so 2x, and then x plus 5. And the right-hand side, minus 9, and x plus 5. And again, you know you're on the right track when those two brackets are the same. So 2x minus 9 is a factor, and x plus 5. Solving for x, we can say x equals, x equals 9 over 2, or 4.5 obviously is the decimal form, or x equals minus 5. Now, we're working with side lengths, so it's important to remember that x cannot be negative in this situation. So here x equals to negative 5 is not a valid answer. Our only answer is x equals 9 over 2. Now I'm not sure if it's can't be negative or probably the more correct thing to say was our side lengths, they can't be 0 or negative. So if we look at this length, x plus 1, if x was negative 5, then it will be negative 5 plus 1 and equals negative 4, and you cannot have a length of negative 4. That's the sort of reasoning I was getting at there. So x equals to 9 over 2 or 4.5 is the only answer, and that's the correct answer, and this gets you the excellence grade. Okay, your merit, simplification of the equation to a quadratic. So merit is here, and your achieved forms the expression for the area. So our first step, the achieved. Okay, question 3 now. It asks the sum, it asks us to find the value of x. The sum of the interior angles in any quadrilateral is 360 degrees. And we've got these angles here, 9x minus 40, 11x plus 40, 6, x plus 5, and 10x minus 3. And they're asking us to find the value of x. The important piece of information is that the sum of the angles equals 360 here. So, finding the value of x, we can say all of these angles, 9x minus 40, 11x plus 40, 6x plus 5, and 10x plus x minus 3, well, they all equal 360. So, 9x minus 40 plus 11x plus 40 6x plus 5 and 10x minus 3, and because of running out of room I'll put 360 equals over here. Okay, so we're going to collect like terms and then we can solve for x. So we've got terms with x in them, 9x, 11x, that will become 6x and 10x, and just your single digits, minus 40, plus 40, that'll be 30. 6 times 5 is 30, so let's just chuck this in here, 30 and negative 30. Okay, so we've got, looking at our x's, we've got 20 plus 6 is 26, plus 10 is 36. So 36x. Looking at our green values, we've got minus 40 plus 40 is 0, plus 30 minus 30 is, again, 0. So it's just 36x. We can divide by 36 on both sides, meaning x equals 10. Okay, and solving this linear equation, x equals 10 gets you the achieved here. Okay, moving on to question 3b. The diagram below shows a sketch of part of the graph y equals ax squared plus bx plus 2. The 2 points Q and R each lie on the graph at coordinates negative 113 and 418. And we can see that in this diagram here. Find the values of the numbers a and b. Now, how do we go about finding a and b? Well, we have these coordinates, so Q is minus 1, 13, and R is 418, and we know they lie because it tells us on the graph y equals ax squared plus bx plus 2. And so we can, finding a and b, we can actually substitute in these coordinates, remembering that a coordinate is written in the form x comma y. So looking at the r, for example, 4 is x and 18 is y. And for the q, negative 1 is x and 13 is y. And so we're going to substitute x and y in to our y equals ax squared plus bx plus 2 equation. So working with r first of all, which is 418, we can say 18 equals, because that's y, a 4 squared plus b times 4 and then plus 2. Okay, q is negative 113. And so in this case it's 13 equals a negative 1 squared plus what is it, bx, so negative 1, b negative 1, and plus 2 again. And I've just run out of room, plus 2. Okay. We can tidy these equations up. We can say, going back to the R, we can say 18 equals 16a, because 4 squared is 16, plus 4b plus 2. And for the Q equation, it's 13 equals negative 1 squared is just 1, so a minus b plus 2. Okay, we can also collect like terms, and we can say 16a plus 4b, and bringing out 18 over, it'll be 2 minus 18, so minus 16, but is that correct? Just checking. Yeah, so it would be minus 16, yeah, but that equals 0. Basically what I'm getting at is two equations here that we can solve simultaneously. So instead of writing minus 16 equals 0, let's say it equals 16. And same for our second equation, it'll be a minus b, and it'll be equals 11. Okay, so we've got these two equations, and we want to find the values of a and b, and we'll do that by solving simultaneously. So there's a couple different, well, there's two ways you can solve simultaneous equations. Obviously the elimination method or the substitution method. I think in this case, and either works, in this case I'm going to use the elimination method. So let's say our first equation remains unchanged, so 16a plus 4b equals 16. Our second equation, we're going to multiply the whole equation by 4. Okay, so it becomes 4a minus, that is, minus 4b, and equals 11 times 4 is 44. Okay, now you can say, in looking at it now, possibly it would have been better to actually divide our first equation by 4, for example. No worry, we can still move forward with what we're doing. We've got 4b and negative 4b, and so we're going to be adding our equations. Okay, so work in columns, so the a's, the b's, and our single digits, we're adding, so 20a, the b's cancel out, and it equals 16 plus 44, which is 50. It's not 50, that's 60 rather. Solving for a equals 60 over 20, which is 3. Okay, b, we can take any of our equations to and find b. Let's take a minus b equals 11, and we can say a minus 11 equals b. Therefore, 3 minus 11 equals b, and so b equals -8. Okay, and with that, we've found the values of our two numbers, a and b. A equals 3 and b equals to -8. The correct solutions for a and b gets you the excellence grade here. Merit, correctly combining the equations into one variable. So that's basically the first step of the simultaneous equations that we were doing. And actually, when I say that, combining the equations into one variable, that's assuming that you do the substitution method. The equivalent for our elimination method is probably here. And actually, not achieved, is it? That's merit. Achieved, you form both equations, so in here gets you the achieved. Okay, moving on to question 3C. Terry is 5 years old. Marty is 4 years older than Murray is 4 years older than Terry. How many years will it take until Terry and Murray's ages in years, when multiplied together, make 77? Okay, so this one, there's two ways of going about it. You could have the original as the variable, so we're going to have this variable x, and you could have the original age as x, and then Murray is 4 years older, so x plus 4, and multiply them. Or you could have Terry as 5, and then do the age of Murray is 5 plus x. Either way works. Let's say we've got this original age. We'll forget that Terry is 5, and we'll just say Terry's age is x. And so we're multiplying the ages, and so Murray's age is x plus 4. Okay, and the question says when multiplied together, we're going to say they equal 77. Okay, so expanding our brackets, we've got x squared plus 4x, and taking our 77 to the left-hand side, it'll be minus 77, and that equals to 0. Factorizing this quadratic, we've got our numbers are positive 11 and minus 7, so x plus 11 and x minus 7, they equal 0. Solving for x, it'll be x equals negative 11 and 7. Now, just thinking about the context of the question, we've found x. Well, the first thing to say is x actually can't equal negative 11. You can't have a negative age. So x equals 7. And what is this actually telling us? Well, that means Terry's... we're saying when our equation is satisfied, so when the two ages are multiplied together and they equal 77, at that point, Terry will be 7 years old. And the question asks, how many years will it take until Terry is 7 years old? At the moment, Terry is 5 years old, so we say 7 minus 5 is 2 years. Okay, so this gets your merit. Achieved, forms valid equation in one variable. So here is your achieved. Okay, moving on to question 3D. The question asks us to simplify as far as possible this fraction 4x squared minus 25 over 2x squared minus x minus 10. Okay, so 4x squared minus 25 over 2x squared minus x minus 10. And we've really got nothing else to do here but factorize. When in doubt, factorize in the MCAT. So looking at our numerator, that is actually the difference between squares here. So 4x squared is a square number, as is 25. So the factorized form will be 2x plus 5 and 2x minus 5. And your denominator, we have to take a bit of time to factorize this quadratic. So 2 times negative 10, just going through this process again, a times c is negative 20. So two numbers that multiply to negative 20 and add to the b term, which is negative 1. And that will be 5 and negative 4, I believe. Actually, what is it? Negative 1, right? So it'll be negative 5 and positive 4. So we've got 2x squared plus 4x minus 5x and minus 10. Okay, so our numerator, well, we're happy with that. That's, again, 2x plus 5 and 2x minus 5. And we have to keep going with our denominator. We draw a line through the center of the equation. And our left-hand side factorizing at 2x and x plus 2. And our right-hand side is minus 5 and x plus 2. Okay, we're almost there. 2x plus 5 and 2x plus 5, 2x minus 5. That's all over 2x minus 5 and x plus 2. And as is usually the case with these questions, we can cancel 2x minus 5. And so we're left with a final answer of 2x plus 5 over x plus 2. And that is the correct equation here. So correct simplification of the expression gets you the merit. Achieved factorizing the numerator or the denominator. So our denominator took a bit of time. You wouldn't get the achieved until late in the process, but factorizing the numerator, that would get you achieved as early as that step here, other step here. Okay, moving on to the last question of the paper. If y plus 3 equals the root of cx squared minus 7 over p, give the equation for x in terms of c, p, and y. So it's a rearranging question. y plus 3 equals cx squared minus 7 over p. Okay, and they're asking us to give the equation once again for x here, so it's going to be x equals. Okay, so the first thing we can do is we want to do the well, we've got the square root, so we're going to be squaring on both sides is the first thing to do. So this is y plus 3 all squared. Obviously the opposite of square root is squaring, and we're left with c x squared minus 7 over p. Now we can multiply by p on both sides, so p y plus 3 all squared equals c x squared minus 7. And now we can divide by c, so it's just a matter of working through it methodically. We've got p is y plus 3 all squared over c, that equals x squared minus 7. Now we add 7, so it's going to be p y plus 3 all squared over c, and that fraction is add 7 onto the end of it, and that's x squared equals. Now we've got x squared, we want just x. The opposite of squaring is square rooting, so our final answer is x squared equals the root of p y plus 3 all squared over c plus 7. Okay, and we got there in the end. Correct rearrangement gets you the excellence grade here. Your merit is you've rearranged the square root and rearrange the squared or the p and the c or the negative 7. So the earliest merit you could get is the square root and the p and the c. So here is probably your merit. And achieved rearranging the square root is your earliest achieved, so this step here, our first step. Sweet. So that's us for the 2020 MCAT. A pretty manageable paper, but certainly it took some time to get through. As ever, if you have any questions or comments, feel free to chuck them in the comment section below. And thank you all for watching. Cheers.